De-Moiver's theorem for complex number. Statement of De-Moiver's theorem. Let theta be any real number and n be an integer. Then cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. This is very simple statement of the De-Moiver's theorem. That is, theta is real number. Theta is maybe in fractional, maybe in point, but n is integer. That is, what is the value of n? Either 0, 1, -1, 2, -2, 3, -3. These are the values of n. The n is integer. And that's why the theorem, the proof of the theorem is in the four cases. That is, suppose n is positive integer, then n is a negative integer, n is 0, and n is a positive integer. Positive integer, negative integer. So the proof is in the three cases. So either n is integer means n is positive integer, or n is 0, or n is a negative integer. So there are three cases due to n is integer. So we prove the theorem only for integer value of n in three cases. And the first case is what? N is positive integer. And what do I have to show? Let theta denote this number, that cos theta plus I sin theta is, let be theta, notation theta for this number. And then z is e raised to I theta. So this is in the exponential form. Modulus is 1 and argument is theta. So e raised to I theta. This is in the exponential form. E raised to I theta. Okay. The value of e raised to I theta is cos theta plus I sin theta. And now what we have to show? This is denoted by z. So we have to prove z raised to n is e raised to I n theta. What is e raised to I n theta? Is cos n theta plus I sin n theta. And what is z raised to n means? E raised to z means e raised to I theta raised to n is what? This e raised to I n theta. So we have to show this. This is denoted by z. So what we have to show? Z raised to n is, this means this is in the exponential form is what? E raised to I n theta. E raised to I n theta is cos n theta plus I sin n theta. That is where to show this now. Okay, in another notation. Suppose the case number 1 is what? N is positive integer. In this case, we prove the theorem by mathematical induction. So n is positive integer, or n is strictly greater than 0, or n is natural number. N is natural number. And now we have to, the proof is by using mathematical induction, and that is, we denote Pn, this statement, by Pn, and the mathematical induction on n. Suppose the step 1, there are two steps in mathematical induction. The first step is what? Prove the result is true for n is equal to 1. So take n is equal to 1. Now what do I have to show? We have to show z raised to 1 is equal to e raised to I 1 theta. That is, z is equal to e raised to I theta. And this is the given. This is our assumption that z is e raised to I theta. And therefore P1 is true. There is nothing to prove. Okay. So the result is true for P1, Pn is true for n is equal to 1, or P1 is true. This is the first step. Now the second step is what? We have to assume the result is true for n is equal to m. We assume that Pm is true for some positive integer m. That is, we assume that the result is true for n is equal to m. That is, what is your assumption? That is, substitute n is equal to m. That is, what is our assumption? Z raised to m is e raised to I m theta. This is our assumption, that z raised to m is e raised to I m theta is true. It's called induction hypothesis, and suppose it is denoted by star. And now what we have to show? We have to show Pm plus 1 is true. That is, the result Pn is true for n is equal to m plus 1. So this is the second step of the mathematical induction. Assume the result is true for n is equal to m, and prove the result is true for n is equal to m plus 1. That is what we have to show. We have to prove the result is true for, this result is true for n is equal to m plus 1. Means we have to prove z raised to m plus 1 is equal to e raised to, in bracket, m plus 1 theta. This is we have to show. Z raised to m plus 1 is equal to e raised to I m plus 1 theta. So consider LHS of that. So z raised to m plus 1 is what? Z into z raised to m. And that is base is same than addition of our z raised to 1 into z raised to m is z raised to m plus 1. And z is what? E raised to I theta. Z is this, Z is e raised to, Z is e raised to I theta, and Z raised to m is by using assumption e raised to I m theta, and therefore it is e raised to I, this I theta plus I m theta, take I common, so what we have, m plus 1 theta, theta also common, and that is what to show, that is the result. What we have to show, the result is true for n is equal to m plus 1, means Z raised to m plus 1 is e raised to I in bracket m plus 1 theta, and that is we have Z raised to m plus 1 is e raised to I in bracket m plus 1 theta. That is the result is true for n is equal to m plus 1, or pm plus 1 is true, and therefore here the mathematical reduction, by using mathematical reduction we say Pn is true for all positive integer or all natural number. Now the case number 2, let n is equal to 0. Okay, so this is the case number 2, and the third case is what, n is negative integer. So Z raised to, what we have to show, Z raised to 0 is e raised to I0, or Z raised to 0 is e raised to I, what is the value of n, 0 theta. So we have to show this, and so what is Z raised to 0 is 1, and what is its value, cos 0 theta plus I sin 0 theta. We can write, because cos 0 theta is cos 0 and cos 0 is 1, and I sin 0 is what, 0, so this value is 1. And what is cos 0 theta plus I sin 0 theta, it is e raised to I0 theta, e raised to I0 theta. That is, we have Z raised to 0 is e raised to I0 theta. Okay, and that is the result is true for n is equal to 0. Right here is equal to e raised to I0 theta. That is the result is true for n is equal to 1, n is equal to 0. Let, then third case is what, let n be negative integer. Suppose n is equal to minus m is positive integer. So suppose n is negative integer, means what is the value of n is minus 1, minus 2, minus 3, minus 4, that is minus some positive integer. N is what, minus some, minus into some positive integer, let it be m. Then Z raised to m is Z raised to minus m is 1 by Z raised to m, and is e raised to I m theta, because Z raised to m is what, Z raised to m is e raised to I m theta, because m is now positive integer, and if m is positive integer, then we know that Z raised to n is e raised to I m theta. That is, result is by using case number 2. Case number 1, the result is true for positive integer. So m now positive integer, and so Z raised to m is e raised to I m theta by using the same theorem, De-Moiver theorem, but by using case number 1, because now m is positive integer, and actually for positive integer, case number 1 says that Pn is true if n is positive integer, and therefore we have, and then it is e raised to minus I m theta, that is e raised to minus m is n, minus m is n, so e raised to I n theta, and so what we have, Z raised to n is e raised to I n theta. That is, the theorem is true for if n is negative integer, and therefore we say that the theorem is true for all integers, that is for positive integer, negative integer, and if n is 0. Okay, this complete the proof. So this is the very simple theorem, but it's very important theorem as far as exam concerned. So what is the question on this theorem? That state and prove De-Moiver theorem. So this is very important question. State and prove De-Moiver theorem. And if your exam is suppose objective type, MCQ type, then the statement is useful for objective. That is, the LHS is given, and what is RHS? There are that its value is what, cos n theta plus I sin theta. So statement is also important for MCQ questions, and the proof is important as far as the exam concerned. So next is suppose Z belongs to CB, complex number, and let W belongs to CB its nth root if W raised to n is Z. So nth root of the number is what, W raised to n is Z, W raised to n is Z. Okay, W is called. So what is the nth root of the nth root of Z? Nth root of Z means Z raised to 1 by n, and Z raised to 1 by n is W, means W raised to n is Z. So W is called nth root of Z if the W raised to n is Z. Find all nth roots of Z is equal to a plus ib. Suppose W is what? W is A plus IB raised to 1 by N. Means what? Means W is nth root of A plus IB. What is the root of A plus IB? Root of A plus IB means in a root, write A plus IB, or write A plus IB raised to 1 by 2. That is the root of IB, A plus IB. What is the third root of A plus IB? It is A plus IB raised to 1 by 3. Like that, what is the nth root of A plus IB? A plus IB raised to 1 by N. This is the nth root of A plus IB. And let it be W. Now we have to find the value of W. Okay. So suppose this A plus IB is in the polar form, R in bracket cos theta plus I sin theta. Be its polar form of Z. That is R is modulus of Z and theta is argument, principal argument of Z. Now A plus IB is R cos theta plus I sin theta. Is R cos theta plus 2k pi plus I sin theta plus 2k pi, because this 2 pi is the period of the sine and cosine function. That is, if you add multiple of 2 pi in the theta, then we have the same value. That is, what is the value of cos theta and cos 2 pi plus theta? Both are same. Cos theta and cos 2 pi plus theta. Sin theta and sin 2 pi plus theta. Both are same. Sin theta, cos theta and cos 4 pi, both the value are same. Similarly, sin theta and sin theta plus 4 pi, both are same. Because this 2 pi is the period. That is, if you add 2 pi or multiple of 2 pi in this angle theta, then there is no change. That is cos theta and cos theta plus 2k pi, both are same for all k runs from 0, 1, 2, 3 up to infinity. Similarly, sin theta and sin theta plus 2k pi, both are same. So we write this A plus IB in polar form, and then it's 2k pi, 2 pi is period, therefore we add 2k pi in both angle. K runs from 0, 1, 2, 3 up to infinity. Then W is equal to, W is the nth root of the A plus IB. Now we assume W is the nth root of A plus IB. And then W is what? Z raised to, W is Z. Suppose this is Z. Z A plus IB. Z raised to 1 by N. That is, Z means what? A plus IB. And its value is what? This. So it's 1 by N power is R raised to 1 by N power. A plus IB value, substitute the value of Z as the value of A plus IB as R raised to 1 by N. Cos theta plus R raised to 1 by N cos theta plus 2k pi plus I sin theta plus 2k pi, this value raised to 1 by N. And then by using the De-Moiver's theorem, what is the De-Moiver's theorem? Cos theta plus I sin theta raised to N is cos N theta plus I sin N theta. So value of N is 1 by N. So this is cos this into 1 by N means theta plus 2k pi by N into 1 by N. This is this into 1 by N means this, and this into 1 by N means this. Okay. So by using De-Moiver's theorem. So what is the De-Moiver's theorem? This is the De-Moiver's. Cos theta plus I sin theta raised to N is cos N theta. That is multiplied by this to theta. So here is N is 1 by N. So multiply this theta plus 2k pi by 1 by N. That is 1 by N into theta plus 2k pi is theta plus 2k pi divided by N. Similarly, this into 1 by N means this. Okay, by using De-Moiver's theorem. And K runs from 0, 1, 2, 3 up to infinity. R is to 1 by N denotes the nth root of R. And substitute K is equal to 0, 1, 2, 3 up to N minus 1 in this. What we have, we get nth roots of Z is equal to A plus IB, and that is suppose denoted by W naught, W1, W2, Wn minus 1. So what is W naught? Substitute R is equal to, substitute K is equal to 0. So what do we have? R is to 1 by N cos theta plus 2 pi, theta plus 2 pi, theta plus 2 into 0 pi, 2 into 0 pi means 0, theta by N, was just theta by N. Substitute K is equal to 0 plus I sin theta by N. This is the first value of nth roots of Z. Then W1 is what? Substitute N is equal, K is equal to 1. We have this answer. Then substitute in this way, k as n minus 1. We have this answer. And this w naught, w1, wn minus 1 are what? Are the nth roots of this z is equal to a plus ib. Find nth roots of unity. In the same case, same type example. Suppose w is nth roots of unity. That is 1 raised to 1 by n is w. Like this, w is what? 1 raised to 1 by n. And therefore w raised to n is what? W raised to n is 1. And what is 1? Value of 1 is what? Cos 0 plus I sin 0. Because this is the polar form of the complex number 1. And then w raised to n is what? Cos 2k pi. Add 2k pi, because 2 pi is the period. Same method. 0 plus 2k pi is 2k pi. 0 plus 2k pi is 2k pi. And then w is what? W is this bracket raised to 1 by n. Shift this n to right side. Then this is 1 by n. Similar to this. Raised to 1 by n. We start with from this z, w is equal to z raised to 1 by n. Z is what now? Z is 1, 1. So its polar form is cos 0 plus I sin 0 raised to 1 by n. And then by using De-Moiver's theorem, this is cos 2k pi divided by n. Actually 1 by n into 2k pi. That is 2k pi by n. Here 2k pi by n. Suppose k runs from 0, 1, 2, 3 up to infinity. And then substitute k is equal to 0, 1, 2 up to n minus 1. We get this w naught, w1, w2, wn minus 1. So if we substitute w0, k as 0, then we have answer cos 0 plus I sin 0, that is 1. Then w1, w2, wn minus 1. These are the nth roots of unity. Nth roots of unity. Suppose cos 2 pi by n, w is cos 2 pi by n plus I sin, suppose this is w. Then what we have? w0 is w raised to 0. W raised to 0 is 1. w1 is w. This w1 is w. No, this is the notation for w. W is this, suppose. Then w2 is what? W2 is w square. If we find w square, then it is cos 2 pi by n plus I sin 2 pi by n raised to 2, means it is by using De-Moiver's theorem, it is cos 4 pi by n plus I sin 4 by n. Suppose in this way, w3 is w cube, wn minus 1 is w raised to n minus 1, and these are the nth roots of w. So in this another way, and if you add this all 1 plus w square plus w raised to n minus 1, then it is what? 1 minus w raised to n divided by 1 minus w. And this is w raised to n is 1. W raised to n is 1. Because what is w? W is this. And its nth power is what? Cos pi plus I sin pi. 2 pi. Cos 2 pi plus. Because n into 2 pi by n is 2 pi. And its value is 1. And so we have 0. That is the addition of nth roots of unity is 0. So we'll stop here. We'll see the remaining problems in the next lecture. These are the nth roots of unity. Nth roots of unity. Nth roots of unity are these. So what are the values of 2 raised to 1 by 4 raised to 1 by 2? What are the square root of 4? There are two values, plus minus 2. Like that, if the power is 1 by 3, then we have the 3 values. If here is the power is 1 by n, that is we have n values. These are the n values. And this is denoted by w. What is the notation for w? Cos 2 pi by n plus I sin 2 pi by n. And therefore, w naught is w raised to 0. w1 is w. w2 is w square. What is w square? Its square is what? Bracket raised to 2. And by using De-Moiver's theorem, it is cos 2 into 2 pi by n. That's cos 4 pi by n plus I sin 4 pi by n. That is w square is w. w2 is w square. Similarly, w3 is w raised to 3. W raised to 3. And in this way, w raised to n minus 1 is w raised to n minus 1. Raised to n minus 1. Wn minus 1 is w raised to n minus 1. And these are the new notations for nth roots of unity, where W is this. And if you add, then we have this answer. This is by using the arithmetic addition of this 1 plus W square W raised to n minus 1 minus W raised to n divided by 1 minus W. And W raised to n, if you find the nth power of this, so bracket W raised to n means the bracket raised to n, and by using De-Moiver's theorem, it is cos n into 2 pi by n, means cos 2 pi, plus I sin n into 2 pi by n, means cos 2 pi, sin 2 pi. And value of cos 2 pi is 1, and sin 2 pi means sin 180, sin 360, sin 360. Cos 360 means cos 0 is 1. And sin 360 means sin 0 is 0. So W raised to n is 1. And therefore addition of nth roots of unity is 0. The sum of all nth roots of unity is 0. The sum of all nth roots of unity is 0. This is important for MCQ question. That is the sum of nth roots of unity. Unity means what? Is what? Is 0. So in the next lecture, we will see these problems. Five fifth roots of minus 1. These are nth roots of unity. These are nth roots of unity means 1. Now we have to find 5 fifth roots of minus 1 in the next lecture.